Hi, we are going to look at writing the formulas for different ionic compounds in this video. So far, you have been looking at formulas and we've been naming them. Well, now we're going to go backwards. We're going to look at the name and you're going to write the formulas. The first thing we need to do is remember the charges of the elements. So, that's also known as the oxidation state, and you've seen a video on that. The charge is the difference between the number of protons and electrons in an atom. And metals tend to lose their electrons and they form cations. And the nonmetals gain electrons and they form anions. Ionic compounds, and they're sometimes called salts, are these compounds between metals and nonmetals, and we've had a lot of practice naming them. The positive charges need to be equal to the negative charges. So that's important. In an ionic compound, the positive charges on the metals will equal the negative charges on the nonmetals. So that's important. So first of all, you need to have the charges on the families memorized. Back in the oxidation states video, we learned some of those charges. For transition metals, the charges are indicated with a Roman numeral that is in parentheses, and that's just the charge on the ion. So here we see iron, and then there's a 3 in parentheses. That means that the charge on the iron is a positive 3. Same thing happens with the copper 1. All right, so let's just review. For these families, our alkaline metals, these guys are +1. Always +1. The alkaline earth, these guys are +2. Now here we are in our transition metals. The only way we're going to know their charge from a name is they're going to have to indicate the charge in parentheses. Except we do know zinc is always +2. That didn't turn out too well. +2. Silver, +1. Aluminum is +3. Okay, the halogens tend to be -1 in ionic compounds. These guys would be -2 and -3. All right. Well, here we go. These are elements that only have one oxidation number, and so we don't have to use the Roman numeral in parentheses when we're naming them. So if you see a zinc, it's +2. Silver's always +1, and aluminum's always +3. That's that staircase we've looked at. And cadmium is +2. And there's mercury 1, which is kind of a special case. It's diatomic, and then it has a +2 charge. We'll talk about that more in class. All right, so let's learn how to write these ionic compound formulas. All right, I call it a crossover method. So first of all, you have to identify the metal and the nonmetal. So this is our set of rules, and we'll be using it as we go through. You're going to write the symbol for that metal and for the nonmetal. You're going to give them each their charge, and then you're going to cross over their charges, and I'll show you what that means. We'll remove the charges and simplify to the lowest terms. So basically, when you're all done, the positive charges will equal the negative charges in that ionic compound. All right, so here we go. Let's do what we were asked to do. Sodium is Na, that's our metal. And chlorine, it's a halogen, and it has a -1. Okay, so we've written the symbols and the charges, and now we're going to do what's called the crossover. So here we go. Na plus Cl minus. So a 1 goes down here, and a 1 goes down there. And we don't really want to have like a -1 by the chlorine. It's just a 1 and a 1. And so it's a 1-to-1 ratio. NaCl. The positives and the negatives are equal. Sodium chloride. Okay, calcium. It's an alkaline earth, +2. Bromine, halogen, -1. Let's do the crossover. 2 bromines, don't worry about the positive, for every 1 calcium. Don't worry about the negative. It's a 1-to-2 ratio. So it would be CaBr2, calcium bromide. Aluminum, boy, that's one that always has the same charge of +3. And sulfur has a -2 charge, and then that's sulfide. So we're going to need 3 sulfurs for every 2 aluminums. Al2S3, aluminum sulfide. Notice 2 aluminums each are +3 would give this a +6, and 3 sulfurs each are -2 would give it a -6. This is the correct formula for aluminum sulfide. Zinc plus 2. Fluorine, halogen, minus 1. We need 2 fluorines for every 1 zinc. So there we go, zinc fluoride. Silver, always plus 1. Oxygen is going to be negative 2 in this case. It's not a peroxide. It's going to be Ag2O1. You don't have to write the 1 afterwards. It's understood. Iron 2. What's the charge on iron 2? Plus 2. Oxygen, minus 2. Now when you do this crossover, you come up with iron 2, oxygen 2, but it's a 1-to-1 ratio. So we want to simplify to the lowest possible whole number. So FeO will do it. Iron 3, plus 3 charge. Oxygen, minus 2. 2 irons for every 3 oxygens. Okay, so now we can go both ways. We can name it sodium chloride, or we can write the formula, NaCl. All right, polyatomic ions. If you're in honors chemistry, you're going to have to memorize that chart. But for right now, have your chart out, have the periodic table out also to help you. And we're going to learn how to just use polyatomic ions. Let's not worry about memorizing them. And I think through using them, we're going to wind up learning them. All right, a polyatomic ion is made up of 2 or more atoms. Excuse me. And they have a charge. Now here's the key. Don't ever separate a polyatomic ion, okay? I'll show you what I mean. All right, so let's go ahead and look at this. All right, ammonium is NH4, and it has a plus 1 charge. And this is acetate, C2H3O2, minus 1. It's a 1-to-1 ratio, 1 ammonium to 1 acetate. So ammonium acetate would have this formula, NH4C2H3O2, ammonium acetate. Okay, iron 3, the charge is 3. Sulfate, okay, SO4, hopefully you know this one, with a negative 2 charge. We need 2 irons for every 3 sulfates. So here we go, Fe2, but you know with a polyatomic ion, we are going to have to put it in parentheses because we have more than one. So remember, keep those polyatomic ions together, and we need 3 of the sulfates. So notice it's SO4, that's sulfate, and we need 3 of them, so use the parentheses. Iron 2 phosphate, Fe2, PO4, 3 minus. Okay, we need 2 phosphates, and we need 3 irons. 3 irons is easy. Because we need more than one of a polyatomic, we have to keep the polyatomic ion together, keep it in parentheses, and then outside of the parentheses you put the 2. That means there are 2 phosphates. Okay, ammonium sulfide. Oh, ide ending. That's just the element S with a negative 2 charge. All right, looks like we're going to need 2 ammoniums and 1 sulfide. 2 ammoniums. Hey, that looks really weird. Looks like we have 42 hydrogens. That's why we need parentheses with our polyatomic ions, okay? We need 2 of the ammoniums. Okay. Sodium, plus 1, group 1A metal. Sulfite, notice the ending is ite, not ide, and not ate. Ite. It's an SO3, 2 minus. And the formula is Na2SO3. And potassium, plus 1, carbonate, CO3, 2 minus, 2 potassiums for 1 carbonate. There we go. All right. Well, hopefully you see how to write these formulas and know that the big goal is to make sure that the total positive charge on an ionic compound equals the total negative charge. And when using those polyatomic ions, don't separate them and use parentheses. All right. Well, we're going to practice this more in class. Of course. We'll see you tomorrow.